Good day everyone, welcome to the Certified Math Majors channel. Now in this video, I will show how to solve mixture and solution problems without using the algebraic variables and algebraic processes of solving word problems. Because usually these type of problems, the mixture and solution problems are treated algebraically. That means you have to solve them by letting one quantity be equal to x and another quantity equal to y and solving using the usual algebraic steps. Now, remember that when you talk about mixture and solution, these two things are different. So when you speak of mixture, it's a blend that is composed of two solid materials, which are of different quantities and of different characteristics. And when you talk of solution, this involves the blending of two liquids of different quantities and characteristics. So, similarly, though, although in concept, these two are different, but similarly, when we talk about mixtures and solutions, they are combined to form a certain ratio. And this ratio needs to be satisfied in order for the new substance to exhibit some certain characters. So, practically, since we're talking of ratio, once we find this ratio of the combined substances, we can actually get the amount of each substance that is blended together to create the new substance. And the idea of getting only the ratio of the substances and not using the long algebraic manipulations in solving mixture and solution problems is what we call alligation. So that's why that's the word here. You have alligation. And this allegation is the procedure that we're going to use in this video to shorten the process of solving mixture and solution problems. Now, let us proceed to some examples. So, let's have the first example here. So, a supermarket sells cashew nuts for 60 per kilogram and Brazil nuts for 75 per kilogram. The manager wants to mix nuts to get 15 kilograms of a mixture that is worth 60 per kilogram. Now, the question is how many kilograms of each kind does the manager need? So, we try to break down the problem. So, the problem involves blending of two types of nuts. One is the cashew nuts, and the other one is the Brazil nuts. So, the cashew nuts is 60 per kilogram, the Brazil nuts is for 75 per kilogram. So then we're asked for how many kilograms of each kind does the manager need. So again, we don't use, for the sake of this video, we don't let any quantity be equal to x or y and then proceed algebraically. We don't do that here. What we do is we use the alligation method. And this is the formula for the alligation method. Simple as that, just the ratio. So this is the formula for the alligation method. That's quantity of the cheaper over quantity of the dearer. Dearer is the expensive one. So the one with the quantity with the higher price, obviously. And cheaper is the quantity with the lower price. In this case, cheaper is the cashew nuts because it's 60 compared to the Brazil nuts, which is 75. So 75 is the much higher price, so the dearer is the Brazil and the cheaper is the cashew nuts. Now, CP stands for the cost price. That means the price of the dearer. So the price of the dearer, again, this is the price of the much more expensive part of the mixture. Now here, again, as I have told you earlier, the expensive part of the mixture is the Brazil nuts, and it costs 75 per kilogram. So let's just substitute 75 in there. Minus the mean price. When you talk of the mean price, that is the price of the new substance that is being formed. So in this problem, that is the price of the mixture containing the cashew nuts and the Brazil nuts. And here you have the mixture, which is worth 65. So the mean price is 65. So again, you have here mean price, so 65, and then minus the cost price of the cheaper. That means the price of the cheaper. Cheaper is cashew nuts, which is 60. So you just subtract it, that gives you 60. Now, what do we substitute here? That's the quantity. So when you say quantity, that tells you how many of each. How many of the cheaper, how many of the dearer. But we cannot find it because that's exactly what we're looking for. So how many kilograms of each? So meaning how many kilograms of cashew and how many kilograms of Brazil. So we don't substitute anything here. We just left that formula right there. So just solve this one here. That's 75 minus 65. That gives you 10. Over 65 minus 60, that gives you 5. So this is now, reduce this, this is 2 over 1. So this is the ratio now. That means 2 parts of the cheaper is combined to 1 part of the dearer or the expensive in order to produce a mixture that is worth 65 per kilogram. That means 2 parts, again, of the cashew nuts mixed with 1 part of the Brazil nuts will give you a mixture that is worth 65 kilograms. But all in all, there are 15 kilograms. That means each part will translate to 15 kilograms. So all we have to do is to multiply the total number of kilograms in the mixture, which is 15, divided by the total number of parts created by the ratio of the quantities that are being mixed. In this case, that's 3. So that gives you 5. So each part is 5. So you just multiply each part here. Multiply this by 5. And then multiply this by 5. This gives you 10. And this gives you 5. So that means the mixture contains 10 kilograms of the cheaper. So the cheaper is the cashew nuts. So the cashew nuts, you will have 10 kilograms. And then 5 kilograms for the most expensive nut, which is the Brazil nut. So the Brazil nuts is 5 kilograms. All in all, the number of kilograms is just equal to 15. So this is how we solve the problem. So if you want to solve this using the algebraic method, you will notice, you will observe, or you will find out that we will come up with the same answer as we did when we just used the alligation. Next example. In a candy shop, chocolate which sells for a kilogram is mixed with nuts which are sold for 2.50 a kilogram. So there are 2 quantities that are being mixed here. Chocolate which sells 4 per kilogram and nuts which is sold for 2.50 a kilogram. So you know now which is expensive. So chocolate, which is 4. So we can directly substitute. The cost price of the dearer is just the cost price of the chocolate because chocolate is the more expensive one, 4. And then the cheaper is the nuts, which is 2.50. So you just substitute there, 2.5 or 2.50, just the same. Then chocolate and nuts are combined to form a chocolate nut candy. So this is now the mixture of the chocolate and the nut, which sells for 3.50. Now this 3.50 is the price of the combined. So this is now your mean price. This gives you 3.5, and this one here is 3.5 minus. Now quantity of cheaper over quantity of dearer, we don't have because that's what we are asked for. How much of each? That means how much of the chocolate and how much of the nuts are being used. So we cannot find any answer here. Leave it blank. Just solve this part here. 4 minus 3.5, that gives you 0.5. And 3.5 minus 2.5, that gives you 1. Now, to make our work easier, we will skip with the decimal part. So move one place. So the ratio actually becomes 5/10, which is equals to 1/2. That means one part for the cheaper, two parts for the dearer are being combined to get the desired mixture, which is 30 kilograms. So these three parts, one for the cheaper and two for the uh, more expensive one, all in all makes 30 kilograms. So to get each part, multiply 30 by 3, that gives you 10. So each part contains 10. So again, ratio earlier is 1 is to 2. To get each part, just multiply by 10. This gives you 20. And I'm sorry, 10 rather. Sorry, this is 10. And then the other one, this is of course 20. So 10 kilograms for the cheaper. The cheaper is the nuts. So the nuts should be 10 kilograms. And then you have 20 for the dearer or the most expensive one, which is the chocolate. So therefore, this is 20 kilograms. So that's how you solve it using the alligation method. Next, number four. The third problem. Nick and Chloe have two grades of milk from their small dairy herd. One that is 24% butterfat and the other that is 18% butterfat. How many of each should they use to end up with 42 liters of 20% butterfat? So although a price is not given, the formula for the allegation can still be used. All we have to do is just substitute it with the percentage. So the higher the percentage, that's the dearer. The lower percentage, that's the cheaper. And then the percentage of the mixture, that is, of course, our mean price. So cost price of the dearer, that means this is the one with the higher percentage. So that's 24. So this gives you 0.24 minus the mean price is the percentage of the mixture. The mixture is 0.20, so this is zero point 0.2. And then mean price is again zero point 0.2 minus the cost price of the cheaper. Cheaper is the one with the lower percentage, so that's going to be 0.18. Now, 0.24 minus zero point 0.2, that's 0.04. And then zero point 0.2 minus zero point 0 minus 0.18, that's gonna be 0.02. So to make computations easier, move two decimal places to make this a whole number. This gives you 4/2, which is 2/1. So two parts of the cheaper, which is in this case the milk with 18% butterfat, is combined with one part of the dearer, which is in this case the milk with a 24% butterfat, has been combined together to result to a mixture that is 20% butterfat. But there are 42 liters. That means these parts here are being combined to create 42 liters. So you have 42 divided by the total parts is 3. So 42 divided by 3, that gives you 14. Multiply each part of the ratio by 14. So this gives you 28. So the cheaper, which is the one with 18% butterfat, actually is 28 liters. And then 1 times 14 is 14. This is now for the more expensive part of the mixture, the one with 24% butterfat. So that is now 14 liters. That means 14 liters of milk with 24% butterfat and 28 liters of milk with 18% butterfat is combined to create 43 liters of milk with 20% butterfat. So problem solved without even using the dreaded variables of algebra. Next, let's have the fourth example. Sally and Terry blended a coffee mix that sells for $2.50. So this one blended a coffee mix and the price is $2.50. So you know now that 250 is the price of the blended one. So this is now your mean price. So just substitute it directly. And then if they had used 40 ml of a coffee that cost 3, how much of another coffee consisting $1 or costing $1.50 did they mix with the first? So the combination involves two coffees, one that costs 3 and one that costs 150. So obviously the 3 is the most expensive, so you have 3 here. And the $1.50 is the cheaper, so you have here 1.5. Now go back here, quantity of the cheaper over quantity of the dearer. Notice that they have used 40 ml of a coffee that costs $3. Now this $3 is just one of the coffees that is being used. So actually this $3 is the price of the dearer coffee, of the much expensive coffee. But we are given the amount of how many milligrams of of the expensive coffee is used in the mixture, and that is 40. So we will substitute here by 40. So we have now quantity of the cheaper over 40 equals 3 minus 2.5, that gives you 0.5. And then 2.5 minus 1.5 is 1. Get rid of the decimal. We don't want to work with decimal. So move 2 places. This becomes 5 over 10, which is equals to 1 over 2. That means 1 part of the cheaper, that is the coffee costing $1.50, is mixed to 2 parts of the expensive quantity, which is the coffee that costs $3, is comprising the mixture that is comprising the mixture that has the price of $2.50. Now the question is, we are going to find the quantity of the cheaper because you're asked for how much of another coffee consisting of $1.50. So all we have to do, since that is 40 there, okay, so 2 parts is 40. So notice that if you have 2 parts, you get 40. So to get 1 part, you just have 40 divided by 2, so that becomes 20. So that means this is 20 right here. So this is now the quantity of the cheaper. So the cheaper coffee, or the coffee that costs $1.50, you have 20 ml, while the most expensive coffee, of course, is 40 ml. So that's how we solve this problem. Last problem we have: how many gallon of a 20% salt solution must be mixed with a 6 gallon of 30% salt solution to make a 22% salt solution? So you're combining two quantities to make up a 22% salt solution. So the 22% is actually the resulting percentage after the two is combined. So that is the mean price. So that's 0.22. You have minus here. And then there are two salt solutions, one that is 20, the other one is 30. So of the two, 30 is higher, so this will be the dearer, so zero point 0.3. And of course, the cheaper is the one with 20% salt solution, so that's gonna be zero point 0.2. And then you have 6 gallon of a 30% salt solution. Again, the 30% salt solution is the dearer or the expensive. Substitute it here, 30. I mean 6, sorry. You got there 6. So you solve that one. That's quantity of the cheaper over 6. That's equals to zero point 0.3 minus 0.22. That gives you 0.08. And then 0.22 minus zero point 0.2, that gives you 0.02. Get rid of decimals. So that means you have 8 over 2. That becomes 4 over 1. So that means 4 parts of the cheaper, which is 20%. So 4 parts of 20% salt solution is mixed with 1 part of 30% salt solution that will give you a 22% salt solution. Now, since you already have 6 and this 6 is only this 6 is for the dearer, which is 30, and based on the ratio it only consists of 1 part, so that means 1 part is 6. So to show that, we can just have 6 divided by 1, or mentally, obviously, if you're going to use mental uh, reasoning or logical reasoning, since 1 part, since this is the ratio is 1 and that's 6, that means 1 part is just 6. So to show it that 6 divided by 1 is 6, so each part is 6. Multiply this part here by 6, so that's 24. That means the cheaper quantity, or the cheaper item of those that are being combined should have, or should be, 24 gallons. And in that case, the cheaper one is the 20% salt solution, this one, so this will be 20 gallons. So that is now your answer. So if you're going to solve this using the algebraic method, this will be the same answer. So that's it for this video. So if you like this video, please click like, and of course subscribe to the Certified Math Majors channel to get updates on our next succeeding videos. So thank you so much and enjoy learning.